Hello and welcome to our webinar about the FetLON protocol stack. I'm Hartmut Quast from WHO Ingenieurgesellschaft in Germany. Let me quickly walk you through the agenda. Who is WHO? Who is who? I'll give you some overview of the FetLON stack. I'll give you some more details about this stack. I'll have some information about the evaluation kit and about the license models that we have. Now, who is who? We are a development partner for customized system solutions. WHO was founded back in 1995 here in the city of Lübeck in northern Germany. We are an owner-managed company until today, and in 2024 we had a 5.8 million euro turnover. We do have 54 employees and we have completed more than 500 projects. We also do research projects so we can keep up with the new trends and technologies. Now, what do? We have development and testing under one roof. We develop customized system solutions for the areas of building automation, for industrial automation, for medical technology, and we can we do the verification for all the products we have developed. We can do EMC measurement, we can do environmental testing. These are the services. We can start in the planning phase, we can do consulting. We do the development of the hardware, of the software, and also of the embedded software. We can do the verification and the validation. We can provide technical documentation such as manuals or data sheets. We can deliver the products that you order with us, and we can support you with the product lifecycle management. Basically, everything WHO develops communicates. So be it over wireless media like Bluetooth, Zigbee, N-Ocean, Wirepass, Matter, DECT, NR+, LoRa, 5G, LTE, the narrowband Internet of Things, RFID, or be it over wired media. In the area of building automation, that's DALI, KNX, SMI, MBus, BACnet, LonMark. And in the area of industrial automation, there's protocols like single pair Ethernet, like Modbus, IO-Link, CAN, Ethernet, Power over Ethernet. Regarding testing, we can do EMC measurement and testing. We can do environmental simulation and testing. We can do laboratory testing. We have a Probed Lab 2 for certifying DALI devices. And for our software development, we have automated test benches. For EMC measurement, we have a standard compliant 3 meter fully anechoic chamber and further measurement equipment. This makes us independent from any laboratories, so we do not have to wait for their time slots. We can decide on our own. And we have customers coming in, but we're of course using this equipment mainly for our own purposes. Let me give you a quick overview of the FetLON stack. The FetLON stack has been developed by FetLON, and it is FetLON who also maintains the stack. And both FetLON and WHO provide engineering services for the FetLON stack. So we can provide consulting, we can provide engineering services for your hardware and software design, and we can help you with the design of the free topology or the RS-485 network interface. And it is WHO who can provide the communications transformer which is required for the FT interface. So what is the FetLON stack? It is actually a LonTalk protocol stack for embedded applications. It is fully ISO IEC 14908 Part 1 compliant. So it supports the regular communication objects like network variables, like configuration properties. You can group these communication objects to LonMark objects, and of course you can have explicit messages. Regarding the channels, we support the twisted pair TP-FT10 channel as specified in 14908 Part 2, and we support the RS485 channel as specified by LonMark. And the best thing is it requires a single microcontroller only, which means your user application, the LonTalk stack, and the physical interface are all combined in a single controller. Okay, let's go a little more into the details. What you can see here is the typical architecture of a LonWorks device. So we do have our microcontroller, and on the bottom end we can see the transceivers, the FT transceiver and the RS485 transceiver. And then we can see the software which is running on the microcontroller. So starting from the bottom, there's a hardware abstraction layer, and this allows you to adapt to your specific microcontroller. Then we have the FetLON Stack, the core itself, which contains the physical layer and the MAC sublayer, the link layer, the network layer. Then we have the FetLON Stack API, and this is where you interface with your user application. And of course then there's the user application itself that contains your business logic. And so, because of the structure that we see here and the separation into the different components, it is possible to transfer the stack also to a two-controller architecture, which may be required because you either already have a hardware or software design which uses a two-controller architecture, or maybe it's required because your application has processing requirements that cannot be met by a single microcontroller. But why is it possible to have it on a single microcontroller? Of course, we need some means for encoding and decoding the LonTalk messages that are being transmitted on the physical layer. So Klaus Fetscher, the owner of FetLON, some years ago developed an algorithm that does just that. And it uses the standard peripherals of a microcontroller in order to reduce the computing time required for encoding and decoding the LonTalk frames. This is a pretty neat strategy, and therefore FetLON applied for and received patent protection for that algorithm. So why is it suitable for embedded applications? It can run on any suitable microcontroller. It can be programmed in C. It uses static memory allocation, so there's no surprises at runtime. It has actually a very small memory footprint, and it has overall low performance demands. There's two different channels we support. Probably the more important one is the free topology channel, the TP-FT10 channel with 78 kilobits. It has certain requirements on the microcontroller peripherals. It requires a built-in DAC which is capable of providing more than 1 megasamples per second. It requires 2 DMA channels, and it requires a couple of general purpose timers. In addition to that, we need a discrete bus coupling circuit, which is actually quite simple. It uses the BV2021 number 8 as communication transformer, and it requires only standard components. Here's some more information regarding the coupling transformer. The BV2021 is a LonWorks free topology and link power compatible communications transformer. It has a very small footprint and overall size. It is an alternative to the Renesas FTX3. It is fully compatible with the FT5000 and FT6050 smart transceivers. It has been designed and tested according to the Echelon compatibility specification, and it has been actually verified by Echelon back in the time when we developed that transformer. It has proven its reliability because it has been used in Vago's LonFTT interface, that is an I/O module for the Vago 750 I/O system. And it is still being sold in quantities, and there have been no issues with this module. So why did we develop this module in the first place, or this coupling transformer? Simply because the FTX3 would not have fitted into the housing of Vago's LonFTT module. That is only a 12mm module in width. And if we had not come up with this solution, that module, that LonFTT module by Vago would not have been realized. Okay, more information on this coupling transformer is available on our website. The other channel that we're supporting is the RS485 channel, and so which supports 39 and 78 kilobit. And the microcontroller needs to have the following peripherals. It needs to have one UART. It needs to have a DMA channel. It needs to have a SPI interface and a couple of general purpose timers. And with the FT channel, it needs to have a simple and discrete bus coupling circuit. But this time it's only a standard RS485 transmitter and some additional components. And overall it has some relaxed requirements on the hardware. The FetLON Stack can easily be adapted to different microcontrollers like NXP, ST or Renesas. And so there's no vendor lock. Your platform simply needs to have the required peripherals for the specific channel, as we talked about before. The FetLON Stack allows easy adaptation to different operating environments, like Sapphire, like FreeRTOS, or it can be executed, of course, bare metal. And that's simply because it's programmed in the C programming language. And the stack offers easy configuration for your application-specific requirements. Regarding the development platform, of course, you need a C compiler. You can use the GCC, but you can use also different IDEs. MCU Expresso Suite would be supported, STM Cube IDE, depending on your microcontroller, but you can use other commercial IDEs like Kyle or IAR. The FetLON Stack includes inline documentation using Doxygen comments. All the structures and the functions are documented. Here we can see an example of a function, and as you can see, the documentation also contains call graphs, which should help you understand the code real quick. There are a couple of configuration tables, which we all know from LonMark's technology. Here we have the default and maximum values that are used for the address and v and alias tables. The sizes can be adjusted in the configuration file. That's actually a central file where you do all the configuration of your application. And the defaults, these are the values which are being delivered with the pre-programmed controllers. I'll get to that in a moment. The FetLON Stack also supports multiple transactions, so that means you can send out a certain number of messages without having to wait for the previous transaction, that is the message that you were sent out before, to be completed. And the number of those simultaneous transactions you can have is equal to the number of network output buffers, which of course can be configured in the central config.h file. FetLON offers an evaluation kit. The evaluation kit consists of the FRDM development board for the MCX N94 and 54 MCUs, and it contains a MCX N947 ARM Cortex M33 dual core. This one runs with 150 MHz. That's actually a quite powerful MCU, and it also has machine learning support. The second component is an Arduino shield. That's the FetLON Arduino shield, which has the bus coupling circuits for the FT and RS485 channels on board. And there's a demo project for the MCU Expresso IDE that comes with this. Regarding the user interface, we have the service pin and the service LED on the FRDM board, and on the Arduino shield we have 2 push buttons and 2 user LEDs. Of course, if you have some more fancy stuff you would like to connect, you could use the PMOD and microbus interfaces. and the FRDM board also has an integrated debugger, so you just need a USB connection to your PC to start debugging. The development kit will be available starting in July this year. The FetLON Stack has been ported to different MCUs. Currently there are 2 ports available for the FT10 channel, and there's 4 controllers which are supported for the RS485 channel. FetLON is working on porting the stack to a Renesas controller, and this may be available in July this year. But as I said before, it is possible to port the stack to any controller which provides the required resources. So which licenses are being offered? There's a runtime license which is available for the NXP MCX N947. Well, that's the MCU which is used in the evaluation kit. With this license you will purchase a pre-programmed controller which has the FetLON Stack in a protected memory segment. You will receive an SDK. With this SDK you will be able to create your application and link it against the pre-programmed library. You will be able to download your application on the target platform and test and debug your application. And then there's the source buyout, which has less limitations, of course. There's one thing that you cannot do. You're not allowed to resell the license. But besides that, there's no limitation on the number of devices that you manufacture. No runtime fee. There's no limitation on the number of different applications or types of devices you are planning to develop. You can use the stack for as many different developments as you like. The source buyout includes all of the available ports. You can port the stack to additional platforms yourself. If at some time in the future you would like to use a different MCU, you can port the stack to that MCU. And we can provide support for that, like consulting services. Or you can give us an order to port the stack for you. We'd be happy to do that. This concludes the FetLON Stack webinar. Thank you for watching. I hope I was able to give you some insight into the possibilities of FetLON. For further information, please go to any of the websites that you can see here. And you can email us, of course, or fill out the contact form on either of the websites. Thank you and bye-bye.